Okay, this video is about completing the square. This is section 5.7, completing the square. So first we're going to talk about this example. How do you solve an equation that looks like this? And the way that we're going to do it is we're going to factor this left side of the equation. So let's go ahead and do that. A is 1, so all we have to do is figure out the two factors that multiply together to give you 25 and add up to 10. And those two factors are positive 5 and positive 5. If I multiply 5 times 5, I get 25. If I add 5 and 5, I get 10. So that means the left side of this equation factors to x plus 5 times x plus 5. You could do this out the general way where you rewrite the middle term and factor, but this is what you'll get. Another way to write that would be x plus 5 squared is equal to 36. The nice thing about writing it this way is I can take the square root of both sides now, and I'll get x plus 5 is equal to plus or minus the square root of 36. Now if I subtract 5 from both sides, I get x is equal to negative 5 plus or minus the square root of 36, which is 6. So here are my two solutions, negative 5 plus 6, which is equal to positive 1, and negative 5 minus 6, which is equal to negative 11. So here are my two solutions. We can plug them back in and check and see. If I plug in 1 for x up here, I get 1 squared plus 10 times 1 plus 25, which is 1 plus 10 plus 25, which is 36. So 1 works. Let's try negative 11. This is going to be very different. Negative 11 squared plus 10 times negative 11 plus 25. Negative 11 squared is a positive 121. This is minus 110 plus 25. This gives me 11 plus 25, which does equal 36. So these are our solutions. Okay, so a problem like this is called a perfect square trinomial. It's something that solves down into a single factor that you can write as squared. So it's a perfect square trinomial. So this factor shows up twice, the same factor twice. So I'll do this problem on the extra help video. And then what we're going to do is, what about when we don't know the third term, can we make it a perfect square trinomial? And the answer is yes. So what we want to do is write x plus something squared. We want to write this as x plus something squared. And what the something is, it needs to multiply together to give me whatever this number is, and add together to give me this number. So if I'm going to add two things together that are the exact same to get this, that's the same thing as saying b plus b needs to equal negative 8. Or 2b needs to equal negative 8. So b would need to be 8 divided by 2, negative 8 divided by 2, which is equal to negative 4. So what I need this to be is whatever this term is divided by 2. So if this is negative 4, and if I'm adding negative 4 plus negative 4, that's how I get negative 8. So if I multiply negative 4 times negative 4, that gives me positive 16. That's what needs to go here in this question mark. So this question mark should be 16. If it's a positive 16, then I can say negative 4 and negative 4 are my factors, and I can write x minus 4 squared. This is the same thing as x minus 4 times x minus 4. If I FOIL this out, I get x squared minus 4x plus 16, which is what we started with. So this is what we can factor it to. This number is 16. The way you find that number is you take this b term and you divide it by 2. So you do b divided by 2, and then you square that, and that's what gives you the number that goes out here. So in this case, that was negative 8 divided by 2 squared, which was negative 4 squared, which was 16. Okay, I'll do this problem in the extra help video if you need help, but the number that should go here is 36. If you didn't get that, then watch the extra help video. Okay, so now we're going to use this concept, and this is called completing the square. So what we're going to do is we're going to combine the last two things that we learned. On the first problem, this left side of the equation was a perfect square trinomial already, and so we could write it as a factor of x plus something squared equals something else, right? This is what we did. Well, this one is not a perfect square trinomial. There are not two factors of 5 that multiply together and give me 5 and then add up to give me negative 12. So what I need to do is move that negative 5 to the other side. So let's subtract that. Now we have x squared minus 12x equals negative 5. And now we have a problem that was like the last one. We need to figure out what goes here that would make this a perfect square trinomial. So we take this b term, we divide it by 2, we get negative 6, and then we square it, and that gives us 36. So 36 is the number that we want to be right here. So let's erase that question mark, and let's add 36. But remember, this is an equation, so I can't just add 36 to one side. I have to add it to both sides in order for it to stay equal. So if x squared minus 12x is equal to negative 5, then if I add 36 to both sides, they're still equal. Alright, now this factors. It factors to x minus b over 2 squared. Okay, so we did this term divided by 2 squared to pick 36, so that's the term that goes here. So b divided by 2 is the term that always goes here. You can check that x minus 6 times x minus 6 does give you this entire term. But in order to complete the square, you divide b by 2, you square it, and that's what goes here. And then the b divided by 2 value is what goes inside as your factor. Let's do negative 5 plus 36. That gives us 31. And now we can take the square root of both sides. If I take the square root of this side and the square root of this side, I get x minus 6 is equal to plus or minus the square root of 31. Let's add 6 to both sides. And now I have x is equal to 6 plus or minus the square root of 31. 31 is a prime number, so there's no way that you can simplify this. That is the exact answer. And this is called completing the square. I'll do this example in an extra help video, but I'm going to go ahead and do this one now. So we're going to do the same thing that we did before. This is our b term. If we divide it by 2, we get negative 4. And then if we square that, we get 16. So we want this last term to be 16. So there's two ways you can do this. We can do this the way that we did it the first time. We could subtract 36 from both sides. And then we could add 16 to both sides. Okay, so that's one way to do it. And this is where we want to get. But another way to do it is we could figure out, well, b divided by 2 squared is 16. So I want this to be 16. How do I make it 16? If I subtract 20, it gives me 16. So that's, oops, not negative 12. So that's another way to do it. I subtracted 20 from both sides. Now this is a perfect square trinomial, and I can solve this equation. So this factors to x, and then what goes over here is b over 2. Well, negative 8 over 2 is negative 4. So this is x minus 4 squared is equal to negative 20. Now we can solve this by taking the square root of both sides, and you get x minus 4 is equal to plus or minus the square root of negative 20. Now we add 4 to both sides, and we get x is equal to 4 plus or minus the square root of negative 20. We're not quite done because we can simplify this, the square root of negative 20. The first thing is it's negative, so we can write this as the square root of negative 1 times the square root of 20, and the square root of negative 1, the mathematical symbol for that is I. So we can write this as I times the square root of 20, but then the square root of 20 can also be simplified because it has a perfect square in it. Square root of 20 can be written as square root of 4 times square root of 5, and the square root of 4 is 2. So I could write this as 2 times I times the square root of 5. And now the square root of 5 is a prime number, so this is as simple as it gets. So I'm going to replace this with 2i times the square root of 5. And this is the simplest solution. X is equal to 4 plus or minus 2i times the square root of 5. I'm going to do this in the extra help video if you still need help. And then the last problem I'm going to do today in this video is a problem where a is not 1. So always before, this a value has been 1. It's been 1 in all of the previous problems. Okay, so we're going to talk about, oh, there's 2 more problems I forgot. Pardon me. What about when a is not 1? So this is how you solve this. First of all, let's rewrite this with the 6x on the other side. 5x squared, subtract 6x from both sides. So 5x squared minus 6x is equal to 8. You could move the 8 over here, but when you complete the square, you often move that last term back, so we're just going to leave it on the other side. Okay, the next step is you want to make this a term 1, and the way you do that is you divide by whatever it is. So we're going to divide everything by 5, and this cancels out here, and so we now have x squared minus 6 over 5x is equal to 8 over 5. And now we're dealing with fractions. Yay! Okay, so then the next step is you got to figure out what goes here. So we want this to be a perfect square trinomial. You do it the exact same way you've done the other problems. You take this b term and you divide it by 2. Divided by 2. Well, when you divide a fraction by 2, dividing is the same thing as multiplying times the reciprocal. So this is 2 over 1. If I multiply, I can multiply by the reciprocal and it gives me the same thing. The 6 and the 2 cancel. This becomes 1 and this becomes 3, and I'm left with negative 3/5. So negative 3/5 is the factor. It's b divided by 2. And then the next step to figure out what goes here is I square this. So if I do negative 3/5 squared, negative 3 squared is a positive 9, and 5 squared is 25. So negative 3/5 squared is 9 over 25. So that's what needs to go here in this question mark. 9 over 25. And remember, I can't just add something to one side of the equation. I have to add it to the other side in order for it to remain equal. Okay, so now I'm going to go ahead and erase all this stuff and move this equation up so that I can continue solving it. Okay, so now I can complete the square. This is a perfect square trinomial now. It's x plus the b over 2 term. Well, negative 6 over 5 divided by 2 was negative 3/5. So that's what goes inside here. And you can check that 3 over 5 times 3 over 5 is 9 over 25, and negative 3 over 5 plus negative 3 over 5 is negative 6 over 5. And then let's add this together. 8 over 25 is the same thing as 40 over 25. If I mean 8 over 5 is the same thing as 40 over 25. My writing is getting much sloppier. So now this is equal to 49 over 25. 40 plus 9 over 25. Let's take the square root of both sides, and we get x minus 3/5 is equal to plus or minus the square root of 49 over 25. Well, this is fortunate because 49 and 25 are both perfect squares. So x minus 3/5 is equal to plus or minus square root of 49 is 7, square root of 25 is 5. So it's equal to plus or minus 7 over 5. Let's add 3/5 to both sides, and our answer is x equals 3/5 plus or minus 7/5. Well, we can simplify this. 3/5 plus 7/5 is 10 over 5, which is 2. And 3/5 minus 7/5 is negative 4 over 5. So we can write that as 2 comma negative 4 over 5. These are our solutions to this problem. Okay, so I'm going to do this one in the extra help video if you still need help. But remember, the first step is to divide by 2, and then everything else is the exact same. Okay, the last type of problem is rewriting this type of problem in vertex form. Right now it's in standard form, and we're going to rewrite it in vertex form. So what we're going to do is we're going to just focus on these first 2 terms. If this was going to be a perfect square trinomial, what would I need to be right? What would need to be right here? Well, it's b divided by 2, 6 divided by 2, squared is equal to 9. So that's what I want to go where the question mark is. So I wish that we had a 9 right here. If we had a 9 right here, I could complete the square. So what I'm going to do is I'm going to take this problem and I'm going to write 9 instead of 2. But then I'm going to, what did I add? I added something to 2 to get to 9. I added 7. I added 7 more to get to 9. Well, I can't just add something, so I'm going to subtract 7 off. You can see that 9 minus 7 is 2. So I haven't actually changed this problem at all right here. X squared plus 6x plus 9 minus 7 is the same thing as x squared plus 6x plus 2. So these two problems are identical, but the nice part is if I just look at this, if I group these together, then I can say this factors to x plus 3 squared, because that's what b over 2 is 3. And then I have minus 7 over here that's left over. Well, this is vertex form for an equation. I have my h value, my k value, and my a value all right here. So you can use completing the square to rewrite something from standard form into vertex form. I'll do one more like that. Y is equal to x squared minus 10x plus what? What would we want to be right here if we could pick any value? Well, b divided by 2 is equal to negative 5. Negative 5 squared is 25. So I would want that to be 25 if I could. If it could be. So I'll make it 25. Okay, but this wasn't 25, it was negative 2. So in order to keep this the exact same, I need to get from 25 to negative 2. And the way I do that is I subtract off 27. 25 minus 27 gives me negative 2. That's fine, it works. So these two problems are now identical, they're just written differently. And now I can rewrite this as x minus 5 squared minus 27. It's rewritten in vertex form, which is really nice. Okay, so that's all the type of problems for this example. If you need extra help, go watch the extra help video.